The complex number z equals 1 minus 4i, where I squared equals minus 1. Plot z and minus 2z on the argon diagram. This is the real axis, this is the imaginary axis. And then show that 2 times the modulus of z is equal to the modulus of minus 2z. So we're going to plot z on the argon diagram to start off with. So z is 1 minus 4i. So you go to 1 on the real axis, which is about there, and minus 4 on the imaginary axis, which is about there. So 1 minus 4. So that's our point z. Next we need to work out minus 2z. So we need to multiply minus 2 by 1 minus 4i. So we write down 1 minus 4y with brackets around it, and we stick minus 2 in front of it. Minus 2 by 1 is minus 2. Minus 2 by minus 4i is plus 8i. A minus by minus is a plus. So now we need to plot minus 2 plus 8i on our argon diagram. So go to minus 2 on the real axis, which is there, and 8 on the imaginary axis, which is there. And we join them up, and we plot our point minus 2z. So minus 2 on the real axis and 8 on the imaginary axis, and that's our point minus 2z. Part B asks us to show that 2 multiplied by the modulus of z is equal to the modulus of minus 2z. So these lines represent length, and in complex numbers it means the modulus. So modulus stands for the distance from that complex number to the origin. So in order to find the modulus of a complex number, we're going to use the distance formula, which is the square root of a squared plus b squared. A representing the real part, b representing the imaginary part. So let's start off with the modulus of z. So z is 1 minus 4i. So the modulus of z is going to be the square root of a squared, which is going to be 1 squared, plus b squared, which is going to be minus 4 squared. So 1 squared is 1, minus 4 squared is 16, and 1 plus 16 is 17, so we get the square root of 17. So the modulus of z is the square root of 17, so 2 times the modulus of z will be 2 root 17. Now we're going to work out the modulus of minus 2z. Well, we worked out minus 2z in the previous question to be minus 2 plus 8i. So again, we use our modulus formula, our distance formula. So we have the square root of a squared, which is going to be minus 2 squared, plus b squared, which is going to be 8 squared. Very important that we have brackets, because if we didn't have brackets here, we would have minus 2 squared, which would give us minus 4. But minus 2 squared is actually positive 4. So we get minus 2 squared to give us 4, and 8 squared to give us 64. And 64 plus 4 is 68, and the square root of 68 will give you 2 root 17. So we got 2 root 17 for 2 times the modulus of z, and we got 2 root 17 for the modulus of minus 2z. So clearly 2 root 17 is equal to 2 root 17, so therefore 2 times the modulus of z is equal to the modulus of minus 2z. Part C. What does Part B tell you about the points you plotted in Part A? Well, we got the modulus of z to be root 17, and the modulus of minus 2z to be 2 root 17. So this tells us that minus 2z is twice as far from the origin, 0, 0i, as z. So we got root 17 and 2 root 17. So this is twice as far from the origin as this is. Part D. Let k be a real number such that the modulus of z plus k is equal to 5. Find the 2 possible values of k. So again, these lines mean length, and in complex numbers they mean the modulus. So modulus being the distance from the origin. So we need to find the modulus of z plus k, and we're going to use our modulus or our distance formula, which is the square root of a squared plus b squared. So z is 1 minus 4i. So z plus k is going to be 1 minus 4i plus k. So all I've done is added in a k. And the 1 and the plus k can go together because they've no I parts with brackets around them, and they are the real part. So the 1 and the plus k go together. So it can be 1 plus k or k plus 1, which is the same thing. But this represents the real part because they've no I parts connected to them. And then the minus 4i is the imaginary part. So this gets labelled as the a, and this gets labelled as the b. So we have our square root, a squared, which is going to be 1 plus k squared, plus b squared, which is going to be minus 4 squared. Again, make sure you've got brackets around your minus 4, because if you don't, you'll end up getting minus 16, and that's incorrect. So we have the square root of 1 plus k squared plus minus 4 squared. Minus 4 squared is plus 16. And we're going to let this equal to 5, because we're told in the question the modulus of z plus k is equal to 5. And then what we're going to do is solve for k, because we want to find the two possible values of k. So we need to solve for k. We need to get the k in its own. So we have the square root of 1 plus k squared plus 16 is equal to 5, and we want to get that k in its own. So we're going to bring the square root over the other side, and it becomes squared. So we get 5 squared, which is 25. We're going to get rid of the plus 16 next, so we're going to minus 16 to both sides. Bring down the 1 plus k squared, and 25 minus 16 is 9. We're going to get rid of the squared part next by bringing it over the other side, and it becomes square root. So you get 1 plus k is equal to the square root of 9. And then we're going to minus 1 to both sides to get rid of that plus 1 to get the k on its own. The square root of 9 is plus or minus 3. And we have plus or minus 3 minus 1. So we've got two values of k. We've got plus 3 minus 1, which is equal to 2. Or we've got minus 3 minus 1, which is equal to minus 4. So the two possible values of k are 2 or minus 4.